Alright, so welcome back to this video. We're going to go ahead and continue discussing translations of functions and shifting these things back and forth. And so in the previous video we saw some visuals and I showed you how to manipulate certain functions and graphs, and we kind of looked at how those things are related, how if we change certain numbers, how that affects whether we shift left, right, or even up or down, and even how if we make a function narrow or wide, or all these different things come into effect. And so now what I want to do in this video is kind of just write all those things down that we kind of discussed. And so we have a function, and I'm going to write this pretty large. So we have a function y, and that is going to equal some number that we're just going to call a. And then we have our function. Now remember the number in front. This is technically the number that's in front of our function. And then we're going to have x. So it's going to be our function, and then we're going to have some plus or minus inside the function. So again, remember that's the number that was inside the function in the previous video. Then we also had some number that was outside. Okay, and so how do these things affect the overall graph? And so let's start off with this number. Let's go ahead and start off with this number on the inside right here. Now this number tells us to either shift left, or we can shift right. And just remember that if we had a positive number, that we moved or we shifted left. Okay. If we had a negative number, then we would do the opposite and we would move right. Okay, so hopefully you remember from that video, and if you don't, just go back and kind of rewatch the beginning of that video. The number on the outside here told us whether to shift, so we had to shift up or down. And so if it was a plus, then we would shift up, and if it was minus, we would go ahead and shift downward, right? And then the number in front, this a right here, would tell us how the graph is affected. So it would either tell us whether it is narrow or whether the graph was wide. And we're going to use two words here. The first word we're going to use is vertically or a vertical stretch. And just remember that we have a vertical stretch if a is greater than 1. Or we could also have, let me erase that really quick. There we go. We could also have a vertical shrink if a was between 0 and 1. And just remember, the last little note that I'm going to make here is that if we have a negative sign, we reflect the graph. And we'll look at a few, we reflect, I forgot the word the graph. And we'll look at a few examples in just a bit. But just take a moment, let this sink in, kind of go back to that old video that we did previously, make sure that everything makes sense here, and then we'll look at an example right now. So hopefully that makes sense. Now let's just dive right into an example and use these ideas here. So example 1. I want to just describe, the directions are just going to be to describe the transformation. Okay, so the transformation. And so here's our function. So let's see. For part A, we have that y is equal to, let's go with, let's see, 4, and let's do a square root x minus 2 plus 3. Okay, so let's start, I guess, from left to right. Okay, so the number in front, right here, this 4 is bigger than 1. So remember that number tells us, so I'm going to circle it. This number tells us that we're going to have a vertical stretch, because it's bigger than 1, by a factor by a factor of 4. Okay, so think about what that's going to look like. This is going to stretch the graph vertically. The number on the inside, this minus 2 right here, because it's on the inside of the function, again, if we look here, it's on the inside. Well, that tells us, remember, the inside tells us whether we're going to shift left or right. And so if it's positive, we move left. If it's negative, we move right. And what we have is a negative 2. So that means that we're going to move 2 units to the right. All right. Now let's look at the last thing here. And that is this number, and I'll do this in orange. So this number right here. And actually, I should maybe circle some more. This is actually the number that's outside. It's a positive 3. So remember, the number on the outside tells us to move up or down. Because it's positive, we're going to move up 3 units. And there it is. There's the transformation of the graph. The next step here is going to be, well, can we actually graph this thing? And so that's what I'm going to go ahead and discuss in the next video. But just to kind of get us started, or as a segue into the next video, let's say this is the x-axis. Let's say this is the y-axis. You have to know what function you're talking about here. And so the function that we're looking at when we're looking at this thing is a square root function. And what gives it away is this square root symbol. And so you got to think about what the square root actually looks like. So the square root function, again, just does something like this. This is y equals the square root of x. Well, let's think about the graph that we have. The graph that we have is going to be stretched vertically by a factor of 4. That means that I'm going to have to grab, like, let's say I grab this arrow here and I stretch it vertically. So it's going to do something like this now, right? But then then what? I then gotta move 2 units to the right and 3 units up, right? 3 units up. So that's essentially gonna do this. It's gonna move 3 units to the right. So 1, 2, 3, and then, 2 units to the right. 2 units to the right. So 1, 2, and then I have to move 3 units up. So 1, 2, 3, and now the graph would start here, but again, it would do the same thing. It's just starting at a different point. And so we've really transformed this graph, or translated this graph. Let's look at one last example here, and then we'll call this video, we'll call it a day for this video. So let's see, part B. If I gave you y equals negative, let's go with 1/2, the absolute value of x minus 4, and then minus 2. So again, we have this equation here. And again, we're just going to describe the transformation step by step. So let's start off with the negative. So the negative just tells us again that we are going to reflect, across the x-axis first. So we'll look at that in just a bit. Or maybe I shouldn't say reflect across the x-axis, depending on how you graph this thing. I'm just going to put that we reflect, right? Or it's going to open downward. Okay. Let's move on to the next number, this 1/2 here. This 1/2, because remember the number is between 0 and 1, this tells us that we are going to have a vertical shrink. Okay, so we're going to shrink this graph vertically. Another word for shrink again would be compress. Okay. The number on the inside, again, this number's on the inside, it was a negative 4. That means that we're going to move 4 to the right. It was negative, so we're moving to the right. And then finally, this negative 2 tells us that we're going to move 2 down. So there we have it. There is our transformation, or there's our description. Now the idea here is, well, how does this graph even look? Okay, well, let's see. We're looking at the absolute value function. So if I were to graph it, let's just say here. So again, I'm just going to do a quick sketch. My graphs are not really that pretty. They don't have to be. Just know what they look like. The absolute value function just looks like this. It's a V. It makes this V shape right here. So it looks something like that. Now, let's think about what's going to happen. The first thing that we're going to do is we're going to reflect So it's going to open downward. So it's going to do something like this now. Okay, so now it's going to do something like that. Maybe I should do this color-coded, right, to match what I've written up there. That might make a little bit more sense. So let me do this in yellow. But again, it's just going to reflect downward. That's this step. I'm going to put a little check there so that we've done that. The next thing is we're going to shrink vertically, or we're going to compress. So that means that if I compress this thing, I'm really squeezing it towards the x-axis. So think about grabbing this end and then vertically shrinking it. In other words, pushing it down towards the x-axis and grabbing this end and pushing it down towards the x-axis. Well, that's just going to make the graph maybe open up a little wider, but we're still going to have that same V shape. Okay, so that's this part. Next, we're going to go to move the graph 4 units to the right and then 2 units down. So 4 units to the right would be 1, 2, 3, 4. And then 2 units down, we would have 1, 2. So we're at -2. So now we're here. Essentially, this guy right here, this point right here that I'm making in orange, has now translated or has now shifted right here. But again, we're still going to have that same V, but it's going to be wide, remember. So I'm going to make my final graph, and it's just going to look something like that. Again, I'm not really interested in getting all the points necessary. I just want to know where this graph is in relationship to the X and Y axis.